To tonight's industry hour. So tonight we will be talking about the aeronautical and aerospace industry. We have wonderful panelists joining us today, and we will introduce them later on in the presentation. But first, I'd like to introduce myself. My name is Kim Loring. I am one of the academic advisors in the first year engineering hub. Joining me is Karen Lewis, a fellow advisor. We're going to go through a quick presentation. And then after it, we will follow with the panelists, and then we will end with any questions and answers that you have for our panelists. So I will send it over to Karen.
Thanks, Kim. You hit record, right? Okay. So again, this is the industry hour for aeronautical and aerospace engineering. So before we get started with our panelists, there's a couple of things that we like to highlight here in regards to career opportunities and statistics. So our agenda is going to begin with the Center for Career and Professional Development, which is the CCPD, an office on campus that I'm sure our panelists have highly utilized in their time here. And then we're also going to have the interview of the professional panel by the School of Engineering Hub, aka Kim Loring, and a Q&A session for all of your questions to be addressed. So if you could just put your questions in the chat, I'm going to be reading them to Kim and the panelists at the end of the presentation. So everybody's questions will be addressed at that time. So the first thing that we want to talk about is the Center for Career and Professional Development, or the Career Center, or the CCPD. It has a lot of different names. They're located over in the DCC, which is directly across the courtyard from the JEC, which is where the hub is. You get all those acronyms in. Now, Kristen Kettering is our engineering liaison. So her contact information and her pictures here for your reference. She is your go-to person as far as career fairs, any kind of questions that you might have about career advice pertaining to engineering majors. Kristen is somebody who is very helpful. So the services that the Career Center offers are career exploration. A lot of our students come in as undeclared engineers, as many of you know, and there might be in our audience today. The Career Center helps do that exploration to find out what your career goals might be, and then to kind of work backwards to make recommendations of different things that you could do while on campus to strengthen yourself as a candidate in those fields. They have drop-in hours Monday through Friday from 1 to 3. We also highly encourage you as a first-year student to set up your Handshake account sooner than later. The information's right on this screen, but you could go to the Career Center's website where it also has that drop-in information so you can, set up your profile on Handshake. You can upload resumes. There's a lot of different things that you could do with that tool. So it's really something that you should customize to make it as detailed and personal as possible. We also have a Discord server. They have workshops. They offer professional headshots. We even have a closet. So if you had an interview and you didn't have something to wear, you can always review or go to the Career Center to connect with them about getting a suit or something professional to wear to an interview. So one-stop shopping as far as the Career Center when it's all things related to your career. Now, as far as aero and aerospace are concerned, we do have two majors now. These are some of the companies that employ our students. So you might find some familiar icons here. And we're going to be talking more about those later. And basically, this is the stats from last year's reported students. The average salary for an aero, it was about very close to 80 grand. The range was between 64 and 91,000 for starting. So this is something that fluctuates year to year, and it's also based off of the students that actually respond to the survey to report their information. So that's just a disclosure so you're aware. But I would say our students are doing pretty well if you do the comparison with all the list of all the majors within engineering here. So I'm going to hand it over to Kim now, and I'm going to stop sharing the screen so Kim can introduce the panelists and have a bigger conversation.
Thank you, Karen. So I'm actually going to have all the panelists introduce themselves uh, and tell us their degree, a little bit about their career journey, and then some activities they maybe be doing outside of work and or school. So I will start with Grace.
Hi, yeah, I've got my notes on my phone, so if I'm looking down, that is what I'm looking at. But my name is Grace Quintero. I got my bachelor's in aeronautical engineering at RPI in 2020. And then I actually went to UT Austin and got my master's in aerospace engineering. I graduated in 2023. Currently, I'm working at a company in Houston called Odyssey Space Research. I am doing mission design and trajectory design and analysis for Artemis 3 and Artemis 4 on the SpaceX Starship side of things. So that is a lot of fun. And when I was at RPI, I did some undergraduate research with Dr. John Christian, who's now, I believe, at Georgia Tech. And outside of work, I volunteer at a local Bayou Nature Center. I spend a lot of time there doing education and outreach. I also have a lot of artistic hobbies that I pick up pretty regularly. I like to do a lot of textile art, like sewing and embroidery and things like that. And in general, I just like to be outside. I like hiking, camping, and going to the park with my dog. So that's me in a nutshell.
Thank you so much, Grace. It's nice to hear that you have activities outside of engineering that you like to do, because sometimes people think that they have to be strictly engineering, and they can't have any of those outside interests. So thank you for sharing that with us.
Yeah.
Uh, I'm going to move on to Dice.
All right. I'm Dice Saito. I'm a aeronautical engineering student, class of 2021. Um, I'm currently working at Leonardo Helicopters out in Philly. I'm on the tilt rotor program as a flight test data analyst. I actually recently got a promotion here, so I'm pretty happy with that. It's always nice to be paid a little bit more and acknowledged about what you do for the company. Um, but overall, pretty much a bachelor's of engineering, and then I'm actually planning my master's in a couple of years. But currently, I'm just working here, working flight test, and in my part time, I actually am in the Pennsylvania Army National Guard. So I get to play soldier for the weekend every once in a while and do some cool stuff. But outside of that, um, I have been getting into working on cars, that kind of thing. Definitely a money sink. Don't get into it. But yeah, overall, life's good.
Thanks, Dice. Congratulations on your new promotion. I will move on to Christy.
Hi, my name is Christy Prado. I graduated this past May with a dual in mechanical and aerospace engineering. It was actually the first semester that they offered aerospace, so I got the conversion just in time. But during my time at RPI, I had a few internships, one being mechanical. Right out the gate, it was just more civil and construction based. So it was nice to do something outside of Aero for a start because the rest was Aero from there. I went on to do flight tests for the Navy for F-18 weapons. After that, I worked at Michoud Assembly Facility in New Orleans, which is the NASA site that builds the Artemis rocket. I was employed by Boeing to do that. And I'm still employed by Boeing, so I did that for a year. I continued my work remotely, and then this summer that core stage 2 actually rolled out to Kennedy Space Center. It's there now, awaiting launch. And I worked on satellites over the summer and some more test design for the next upper stages of Artemis 3 and so on, which is what I actually continued doing remotely this year. So I never stopped working for them since 2 years ago. So yeah, it's nice to always keep in touch with what's going on.
Thanks, Christy. Now, are you still doing your graduate degree at RPI?
Oh, sorry.
No,
Yeah,
no problem.
I'm doing my master's at RPI, and if you haven't heard about coterm, it's basically 1 year master's program that you can go straight into right after bachelor's. So I'll have my master's by this May.
Awesome. Thank you, Christy. So I'm gonna go right into the questions. So this is for everyone. What inspired you to be an aeronautical or aerospace engineer? And I'll start with Grace.
Yeah, so I might not be the most useful to someone who's still undecided in college because I knew kind of for a while that I wanted to be an aerospace engineer. My parents got me into sci-fi when I was young, books and movies. I always really looked up to Ripley in Alien. I thought she was the coolest person. So, yeah, I thought that space was just somewhere that I wanted to be. And of course, when I was younger, I felt like, oh, if I can build a rocket ship, like who's not going to let me go to space? Like I can do that. Of course, now I know it's not a one-man job. It's like a hundreds, thousands man job. But that is what initially got me into aerospace. And that's why I, applied to RPI to be in the aeronautical program.
I'll hand it over to Dice.
Good. Similar story. It's just not with space. It's air shows. So I went to a lot of air shows growing up. So you hear F-16 jets flying overhead. That does something to a small kid that's very impressionable. And maybe too much so because I joined the army, right? But I definitely that impact helped me kind of solidify, okay, I want to work with aircraft. I want to start being in the areas that they fly in, work towards something along those lines. So I actually applied to RPI as a civil, actually, and I got in at the civil because I thought civil structures, aircraft structures, it's the same thing, right? And I was quite quickly told to go to the Aero program instead, and that's kind of how I got into Aero specifically. But since the start, I've always known that I wanted to work in aircraft. So unfortunately, if some students are not sure what they want, I don't think I could give the best insights since I'm kind of a hardcore aircraft nerd. So
Sounds like you found your place. That's all that matters. And it shows that students don't have to know exactly what they want to do when they come in, or even if they're possibly in the wrong major, we can get them in the right one.
yeah, don't
Christy,
worry. There's a way to get to Aero or get out of Aero if you really don't want to be here. But it's one of the
yeah,
best degrees in my opinion. So
thanks, Dice. Christy, what do you think?
Um, kind of similar. I was always interested in space, particularly in like the human space flight side of things. But I did decide to do the dual because I had a feeling that once I got to, starting my classes, like there might be a possibility that I would want to work on cars or buildings. And like I think, well, I thought at the time that mechanical was broad enough for that, and it turns out it is all that plus more. And I ended up doing a lot of work, I think, in other fields of engineering. So it was pretty cool to have like both of them.
Thanks, Christy. So I'll move on to the next question. This is for Grace and Dice. Can you walk us through a typical day in your life as an engineer? Additionally, what aspects of your job do you find most rewarding and most challenging?
Yeah, so typically I start my day, I go into the office and I keep notes, like handwritten notes of the things that I'm working on. And so I'm just like, okay, where did I stop yesterday? What do I need to start with today? So my primary role, as I mentioned earlier, is mission design and trajectory design and analysis. So I actually spend most of my days working with a software called Copernicus, which no explanation I can give you of Copernicus would probably do it justice. It's really an impressive piece of software that I do all of my trajectory design and analysis within. And if I'm not working in the Copernicus user interface directly, I am working in a Python environment on the back end of Copernicus. Looks like Dice just lost power for a second. But so I'll be working with Python to interact with Copernicus on the back end. Or at the end of my projects, I spend a lot of time pulling large amounts of data together into plots and presentations that I can then give to the customer that makes sense because I've been working on something for months and they're seeing it maybe for the first time. So I have to make sure I'm not like confusing them and I'm giving them, the information that they need to make decisions. In terms of my work, I definitely enjoy like a more academic environment. I like a research position, and I do find that my job is really rewarding because I feel like I'm doing a research project every time I get a new task. I work with a lot, I have my master's. I work with a lot of people who either have PhDs or who have decades of industry experience. So I have people teaching me new concepts in astrodynamics. And it's also really satisfying to, be on teams with a customer and just be able to, concisely explain everything that I've been working on and have them be like, okay, yeah, this is actually great news. Like we can afford this or this will work for us. So that is definitely extremely rewarding. I will say on the flip side of things, a study doesn't come together overnight. And sometimes it can feel like you're drinking from a fire hydrant when you start a project. There's just so many things that you have to consider. I definitely try to put a lot of thought into what I'm doing. And, you know, in human spaceflight, like things, at least I found things shift a lot. Like, and sometimes I don't know that some things shifted because like there's so many different people doing so many different aspects. But if something shifts in one group, then that changes everything that I'm doing and I have new constraints. So I think that that is probably one of the harder parts of my job is just keeping up with everything because these are spacecraft that are under like heavy development, especially in Artemis 4 because that is still farther away. So yeah, just trying to hit a moving target sometimes can be hard, especially because I want to be very thorough because this is like a human spaceflight project. There are people involved, and I want to make sure I'm not like making an erroneous assumption that causes problems down the line. But there are a lot of checks and balances between me and like the final mission profile. So, that is something that is always comforting when I'm doing my work.
Yeah. Honestly, similar for me. So it sounds like I'm on the other side. So I'm part of a program that's been in the works for the last 2 decades. We say we're gonna hit the finish line next year. Next year, we've said that for the last 5 years. However, the interesting point, I'm gonna go kind of jump around the questions for a second. But the interesting point with that is that I actually work with documentation that was signed in 2007. And I have to read it, understand it, and I can't talk to the guy who wrote it because they're no longer with the program. So it turns into a little bit of a myriad of questions of, what is the intent here with this document? So that was one of my challenges. On the flip side, working in flight test, we work a very fast ship at times, and it's a very slow ship at times. Usually in the morning, we'll get in 8 o'clock pretty early for our standards sometimes. Well, I mean, sometimes we'll come in at 7 if we're really crazy. But we'll do like a little stand-up meeting, get to know what's the issues, the roadblocks on the aircraft for a flight test. And unlike space systems, our flight tests are daily, not once every, couple months, hopefully. So we are pretty fast on briefs, debriefs, emergency procedure planning, making sure our cards are up to date. And that's more of the flight test engineer side. So I actually work with the data analyst side. So I crunch numbers more of, hey, we just had these kind of data points. Are they good, bad? Data management, that kind of thing is really the bread and butter of our daily. But when we're flying, the data analysts are in there too. We work with basically our limits telemetry. So we kind of look at the numbers of the entire aircraft and try to parse through the noise, if you will, and try to spot any unsafe flight condition. We are working with a program that, it's old, and some of the aircraft we were using are on their, last legs of their lifespan. So there are problems that crop up. We have, aircraft down for a week or two extra because we have this component that broke, and guess what? The company that made it isn't the company anymore. They're gone. So now we have to figure out how we're going to work those problems. And I think that's like the most interesting part about this role is just like every day is a different problem to fix. And that can get tiring, I will admit. But some days it's like, hey, we need to go do this, and we just get it done. And everyone comes home, everyone goes out for a beer or two, and then start the next day. So
Thank you both. That was very insightful. Um, Going on to the next question, how often do you guys collaborate with other engineers, other departments? And then you guys kind of touched on this part a little bit, but how much time do you spend in the office, the lab, on site? And I'll start with Grace again.
Yeah, so I've got a pretty small team. I'm working at a company that's contracted with NASA. So my team is composed of people who work at my company and then like civil servants and also a couple contractors that are working on the same project that are from other companies. So I definitely consult with my team members like every day or every other day, depending on what is happening that week. For the most part, honestly, most of our exchanges are just, oh, I'm asking a question, or someone asked me for clarification on something and I'm answering a question. But I find that at least at my level, because I'm a newer engineer in the industry, I kind of just do my own thing. I'm sure the higher I go, the more people will be like, wait, we need this from you, we need that from you. But I kind of, and a lot of members of my team are left to their own devices to work on their projects in the ways that they see fit with, the occasional check-in. So in terms of other departments, I'm horrible at remembering like who's in a different NASA department than I am. In my mind, I'm like, we're all doing guidance, navigation, and control. So like, we're kind of all just the same. So like in my mind, I'm just interacting with everybody who's in the same boat that I am. And I'm definitely like I am not like talking to like structures engineers. Like I'm very kind of siloed in GNC. Of course, structures and communications and all that stuff like plays a role in the work that I do, but I myself at my current level am not responsible for like having those conversations. And then in terms of being in the office, being on site, I spend most of my time either in the office in person or working like from my home office. And then occasionally, I mean, my office is like literally 5 minutes down the street from Johnson Space Center. So I do have meetings there sometimes that I have to go to, if I have to like find somebody that's not answering a Teams message, like that is kind of when I'll be on site. So it's a little bit of a mix, but I'm mostly in the office, in the Odyssey office.
yeah, the unfortunate thing with a flight test program that we try to fly every day is you're on site every day. So that I actually don't work from home at all. My home office is literally my personal laptop and desktop setup, and that's it. Never plug in my work laptop in there. But in terms of working with people, kind of like what Grace said, on Grace's side, I'm going to put this in context. People are going to be asking things from her department. I am that department that asks stuff because when we're flying out there and there's a problem, you're going to get a call from me asking how do we get through this or what's the issue. And even on the ground when we're not flying, there's always questions that flight test needs to understand. So we'll always go to the subject matters and start asking some questions. And sometimes those questions can be, does your system even work? Like, does it work? And sometimes the answer is yes, and the other times it's no. So getting through that kind of thing, it's actually a little bit more interesting with my department because Leonardo is the largest civil helicopter manufacturer in the world. The HQ is in Italy, and the majority of the engineering base is in Italy. So you can imagine all of a sudden, I start saying ciao and grazie because you work with Italians every day. And in the morning meetings are very important for us. That's when we have overlap with our Italian counterparts. So all of a sudden, I'm calling my counterpart and asking questions. He's calling me about some of the issues that we're going to face today. And so these meetings kind of become pretty collaborative very quickly. I pretty commonly work with our mechanicals who are in our drive systems department, our fatigue department, and both sides of the pond, both in Italy and in the United States. So it can get pretty wild pretty quick when you have to go to one person, you get 3 new names, And now you have to call all 3 names and figure out who else is going to help you. And they give you 2 names. So you can see where it kind of cascades down the line. And you have to start tracking out, okay, this person gave me this information. It becomes a mystery almost. And you're the detective. So yeah.
Thanks, Darius. Christy, do you have anything you want to add on that question?
Yeah, so uh I guess I could kind of say like a mix of both of what was just said. I guess it depends if I'm, working through school or there in person, but I was fortunate enough that both summers that I was in person, I was on the like more of the manufacturing side of design engineering. So I was doing wire harness design, which is basically a lot of electrical components and cables that are all throughout rockets and satellites. So when I started in New Orleans, my desk itself was not in a cube, and it was just on the production floor and final assembly. So I was probably like 3 feet away from core stage of the rocket. So a lot of my everyday job was like to go inside of inner tank or go inside the engine section and forward skirt of like the entire rocket. So it was pretty cool to actually get inside them and work in there. Mostly alongside technicians. And then once in a while, like NASA themselves would come and ask questions and check everything. So it was my job to kind of navigate the model software that we have and answer the questions based on that while they're standing there and we're all looking at it. Um, when I moved over to satellites, it was the same sort of thing. So I was instead of in the rocket, I was just working on the satellites, which were a lot bigger than than I expected them to be. But I think I learned best hands-on, and now that I'm back working on Artemis test design, I'm kind of missing being there in person. But it's cool definitely to like sort of plan things that are really far out in the future and then, watch them go through the whole way.
Thanks, Christy. Uh, this is for everyone, this question. Could you describe your undergraduate experience? Did you engage in any internships, professional groups, extracurricular activities? And do you have any recommendations for organizations or clubs?
Yeah, so my undergraduate experience was a bit of a trial by fire. You know, RPI, some people, get it right away. Some people don't. I did not. So I was definitely a little bit clueless when it came to internships. So instead of doing like technical internships, I ended up working a job at the university that first summer as like a STEM camp counselor. And then my second summer, I actually worked at up in Schenectady, the Museum of Innovation and Science, as an educator and someone who did outreach. And I ended up working there for many months after that summer as someone who I wasn't in charge of, but I partially ran the observatory there and did like public viewing nights. So that was definitely an experience that I recommend. I don't think that like outreach and education get enough of like a spotlight. Um, and I do think that it was good on my resume. Like if people are thinking about that sort of thing, like I do get questions about it when I was interviewing. And it is something that I think people now view me as like a more well-rounded candidate when I was interviewing. And a lot of people in industry can see that kind of work. And even though it's not technical work, they do respect that you are like doing some kind of like STEM outreach and stuff like that. So I think it is like worth your time at everybody who's like interested in that sort of thing. I really didn't do a lot of clubs, but for any like fixed wing airplane interested people, I know that Design Build Fly was a pretty popular club. Dice over there, he gets it. Yeah, I know that one was really cool, and it's a really good opportunity if you're interested in fixed wing. In general, I know as a freshman, you're kind of like, well, I want to do everything. And, there's a lot of thoughts of like, will this look good on my resume? Will this make me more employable? I would say just like do what you like, do what you're passionate about. do something with a group of people that you care about and that you get along with, and then you will like kind of find your way. I know that's maybe a little corny, but like I really think that like, you know, piling on a bunch of like extracurriculars is just going to detract from your time at RPI, and it's going to be exhausting. So really I'd say just like look into the clubs there and find what you really care about, and you know, try it out, because that is going to be like worth your time for sure. Oh, and also undergraduate research. I would highly recommend that. That was like my first like dip into the industry for me, into like higher level engineering. Again, I work with Dr. Christian, who's no longer at RPI, but I know that that's an opportunity that still exists at RPI. Like it's totally worth looking into. I think it's for like slightly like probably like juniors and seniors more than like freshmen and sophomores, but you know, it's worth like getting to know your professors and potentially getting into their research groups if they're doing something that you care about. It's really a great opportunity, and I made connections doing that I like still have to this day that have like helped me get to where I am. So definitely recommend that.
Yeah. On that, piggybacking right off of it, I actually was in a student research my freshman year, which is crazy. I just walked to Dr. Kopsov-Topoulos' office and I was like, "Hey, you sent this email out about an opportunity for undergraduates. I'm interested. And I was actually in DBF. I did all 4 years, um, and so I was like, "Hey, I know how to make UAVs, or I know some of it at least. How can I help?" And that year we had our proposal published. So technically, I get to say I'm published, even though it's not a full research paper. Um, it's always fun to get to put that somewhere. But definitely for me, I was actually part of the cohort that had to do Arch. Had to, keyword. So I struggled with that quite a bit. But I kind of found my way. I had a internship with Safe Flight. They're a instrumentation company for fixed wing aircraft and helicopters. So that was kind of my beginning start to internships. I only had one, but it definitely helped along the way. It gave me a talking point, talk about some of the experiences that I was able to do. But overall, I would say for clubs, I am biased, DBF all the way. I all 4 years I did that. But it really did give me an opportunity to actually sink my teeth into project management, leadership with engineers, which let me tell you is a little bit a different animal of leadership when you need to talk to someone who probably didn't really know how to talk to you until you walked up to them and started talking to them about their hobbies. They're like, "Oh, this guy's kind of cool," and then they start talking to you, and you finally have a dialogue. But that's kind of like the nature of the beast in terms of leadership. So always, I push people to try to find opportunities where it puts them in the uncomfortable situation. You might not be confident with your oration skills. Go join a research team and go present their research, right? It's gonna do so much for you. So, you know, have fun, but always remember, if you don't like doing something specifically because it's, a little bit iffy, maybe go out there and do it and just see how it goes.
Yeah, I'd like to kind of piggyback off that as well. I did undergraduate research. It was actually chemical engineering research, and it was with Corey Woodcock. And I did that for about a year. I think it was for my entire junior year. It was with NASA's Glenn Research Center, also partnering with NJIT. So it was cool to like, um, be able to work with other universities. And also it was I guess my first introduction to anything, NASA, anything working with them, which was pretty cool. We basically had meetings with them every week, and other than that, it was nice to be able to present that information and actually have like my first experience, presenting work that I've done for like over a long period of time, rather than just like a regular class presentation. Other than research, I joined a couple clubs. I joined SWE. In my first couple of years, I was on a couple of committees for them. It's definitely nice to be able to be part of that kind of community here, especially where it's so male dominated in the engineering field. Um, I also joined a sorority, which along the same lines really helped when everyone was kind of struggling with the same sort of homework or how to study, or just being able to get advice from people who had already been through what you think might be the worst at the time. So I think it's really important to stay connected within the campus community, whether it's through clubs or just going to events like today. We had Space and Technology Day, and there, if you went, you were able to like even meet some of those speakers who were like lead researchers, scientists, and astronauts. So I think even those are pretty important for networking.
Thanks, Christy. So this next question is going to be for Grace and Dice. So some students always come to us, they're like, am I going to get a job? Is there enough positions in aeronautical, aerospace engineering? Am I doing something wrong? And we try to say, no, you're going to be okay. But can you guys give us your insight on the industry and positions?
Yeah, I mean, there are jobs out there. As of 2023, which is very recently, that's when I was applying for jobs, and it was, in the spring semester. So that's when a lot of people are going to be applying for jobs. There were a lot of very different opportunities. Of course, I got rejected, a couple times, a few times, maybe several times. But it wasn't because there was like a lack of jobs. I wasn't struggling to like find opportunities. Of course, please take what I'm saying with a grain of salt. I do have a master's degree. So, like, in some ways, that makes me a little bit more marketable. I know experience is something that people struggle with when they're fresh out of college with a bachelor's. I know a lot of jobs are looking for like, oh, 2 years or a master's. So that can be difficult. And I kind of had that leg up there. But there were definitely a lot of opportunities just overall. And I was also really picky because I, personally just don't want to do defense work. So I was like really scared when I was leaving school that I was like not going to be able to find anything. But obviously I found something, and not only did I find something that's not defense, I also found out that there's plenty of work to do that's not defense. And of course, there's plenty of work to do in defense if that's something you're more interested in. But in general, I really don't think that there's like a lack of jobs in aerospace. There's so much, especially in space flight, which is what I know. There's so much going on. There's so much going on like all the time. There's always a new project. So there's really just a lot of opportunities out there.
Yeah, it's the same for helicopters industries. There's there's a couple pointers to this one. I'd say there are opportunity. They might not be the traditional sense of aeronautical engineering you might expect. One of the big things that my company faces that has difficulty is having a good connection with our suppliers who give us our line replaceable units. So those are LRUs, we call them. That's a pretty standard industry terminology for all the people who don't know that. But I say we work with engineers, aeronautical engineers who work in instrumentation or who work in specifically avionics, and their background's in aero, but they work on a computer system and it's just installed on our aircraft. So just from that, like even from a perspective of testing, there are plenty of testing companies out there that will test your aircraft for you, or the components for your aircraft. And there's plenty of people on those teams that have backgrounds in aeros, but even mechanicals, electrical. So there's a wide, broading kind of aviation, aeronautical is pretty broad in terms of opportunities. It's just more of what you're willing to accept and not accept, and what you're comfortable working. Right, like Grace mentioned, she's uncomfortable with defense. I personally didn't really have that issue, but I don't know, I drink the Kool-Aid, if you will. So from that perspective, it's a little bit different. But there's plenty of opportunity for helicopters out in the Philadelphia area. there's 3 companies out here that do helicopters. Leonardo's the biggest one, followed up by Boeing at Ridley Park. And we also have Lockheed Martin and King of Prussia. So there are opportunities even in this area. I would say in terms of future, we're going to start talking a little bit in the future tense here. I like eVTOL, so electronic VTOL aviation. Kind of think your DJI drone, but bigger, right? There is a huge industry and a lot of investment going into that industry right now, and that might be up one of your guys' alleys. And I would highly suggest you look into companies like that if you are searching, because that's part of the future right there. Is the more accessible vertical lift technologies that people are trying to make.
Yeah, and just really quick, I want to be clear, you do not need a master's degree to be employable. Like,
Yeah, that
no,
too.
yeah, do
I
not
have a
let that be your
bachelor's.
takeaway. So
I
I
have
just
a
don't want to
bachelor's.
speak to experiences that I don't have. But yeah, you do not need a master's degree to get a good and interesting job in aerospace.
And to add to that, I actually had a PhD student when I was at RPI give me a little stern talking to about me thinking about getting a master's. At the time, I just wanted a master's. That's for the sake of it. I didn't have any research thought process, nothing. And he literally looked me in the eyes and said, "How the heck do you know what you want to do for the rest of your life and specialize in it if you've never worked a day in the industry?" And I went, "Oh, that's a good point." And I went off to get a job instead of pursuing a co-term. So yeah, you don't need a master's, but it can help if you have it. But I would highly suggest you think about the research that you're going to be doing with your master's, because that can kind of filter you into a specific working group that, it might cut down your odds of getting a job or not just because of how niche it is. Uh, so, it's all give and take, right? That's all I got to say really for that one.
No, you guys both bring good points to these questions that we hear all the time. And a lot of times people think, oh, a master's degree is always better, or a dual degree is always better, or a double degree is always better. And in that case, based off of what you guys are explaining, that's not always the case. It's an individual basis of what they're planning on doing. So a lot of times we even say like, hey, would like they want to be more marketable is usually the phrase we hear as advisors. And we're like, okay, marketable towards what? And the answer is, I don't know. So going back to what Dice just said, well, how do you know if you've never had that experience? You've never tried it in a club or tried it like in an internship, or you haven't had like a situation where you've seen the need for it versus just doing it because your friend is doing it. So thank you so much for bringing that insight into this hour. I am going to move on to the next question because we're closing down on time. Um, have you guys noticed any particular specializations within the engineering field that are in higher demand? Specific skills, qualifications, anything like that?
Yeah. So first of all, if I look distracted, my dog like entered 5 minutes ago. So I promise I'm not just interacting with like a ghost over here. But so in my corner of aerospace, and something I found after I started working with Dr. Christian, like my junior summer, guidance, navigation, and control engineers are so desired in space flight. Like you can find so many flight software positions open, and people are looking for guidance, navigation, and control engineers who know how to do that kind of work. Of course, like GNC is such a wide field, like so much goes on in there, with like so many skills and so many different experiences. But making sure like you know where your spaceship is and you know where it's going are like very important as one might think. Some I would argue one of the most important things, but I'm also biased because I'm GNC. So in terms of skills and qualifications, if you're looking, one of my biggest recommendations, if you're looking to go into space flight, is familiarize yourself with softwares that are used in industry. And of course, not all of them are accessible. Some of them you need licenses and stuff like that. I know Dr. Anderson in his junior level, like spacecraft dynamics class, he introduced me and my classmates to a software called STK, which I think he had like a special license for, like RPI had a license for, so that he could use it in his class. I, of course, work with Copernicus, which I mentioned earlier, which is a mission design software. And that is also something that I have like a special license through my job for, so it's not something you can just pull up. But if you're interested in like mission design, trajectories and stuff like that, and also like navigation, I recommend GMAT. And I've not used GMAT, just for clarity. This is just something I know of. But I believe it's open source, and also Free Flyer, which I looked into last night because it's a name that gets tossed around a lot. But I saw on their website that it's free for university students. I'm obviously not sponsored. I have not used either of these softwares, but their names get mentioned in my industry. And I just definitely recommend, if something is accessible to you, try it out. Like, and I know at least GMAT, I think, has a bunch of YouTube tutorials. Maybe Free Flyer does too. Like, there's people talking about these things and doing tutorials online, and they're definitely worth looking into just to try out, because it will give you a leg up. You know, if you're looking for something to make you more marketable, like having those kinds of skills, that is definitely like a resume builder. Other than that, coding skills, you like, you know, at NASA, they love Python. They really do. And Python, you know, is open source. Anybody can really use Python. So I would recommend that. And also in flight software, C, and I think maybe more C++. Those are languages that I recommend you, you know, just dipping your toe into, especially as a freshman. Like, you don't need to drown yourself in them, but like just looking into and starting to get comfortable with those things. Because those are like marketable skills that interviewers and companies are like looking for like internships or careers. So
Yeah, definitely Python. I actually use it every day. So as a data analyst, I look at numbers and plots and charts. So I use Matplotlib, which is a software package part of Python that you can download to really plot all my work, really, like any radial plots, you know, FFTs, anything like that. So I'll just push it through a Python script I wrote up and get it to go. So that's definitely one skill I would highly suggest you have. I do think that RPI Aero students now need to take a engineering programming course that's in Python, right? That's what I heard. So I believe, you know, you're already on the right track by doing this one. Similar to the comment of the GNC engineer is the best. In helicopters, we use flight controls, very similar. Just let me tell you, it's completely different for how to control a helicopter. The thing wants to vibrate itself apart, so you're really trying to control that. And the flight controls realm of helicopters is actually up and coming. There's a lot of demand for it. Back in eVTOL, that's all electrical. So having some knowledge of flight control systems, guidance, navigation, and control, or even just like a baseline understanding of electrical work, like from your physics 1 and 2 classes, can really help keep a leg up from the competition. I'd also say like soft skills, right? I mentioned leadership earlier, but being able to lead a small team of engineers to commit to a task and complete it is highly sought after. Once you get to the workforce, you're kind of expected to be able to be your own leader, at least for yourself. And as you go along, you know, slowly get to climb the ladder, and slowly people are like, oh, well, now you're responsible for these 3 people and these 4 people. Oh, this team of 20. And it slowly ramps up until hopefully by the end of your career, you're at the very top, and you're kind of looking back and saying, oh, look what I did. But leadership is every day. So I would highly suggest that. Sorry, I have a little list because I ran around the managers here asking around. But one thing that pointed out to me was fatigue. You know, you don't really think about it, but aircraft, like fixed wing aircraft, helicopters, they're all vibrating. They're all deteriorating over time with fatigue. I'm sure rockets are kind of similar. I don't know how long your mission life is, so I assume not nearly as difficult at times, but also, I mean, you guys vibrate pretty quickly. So, but I think that at least having that background of that niche skill, the fatigue analysis, the structural analysis, CFD, all of those skills play a part in selling who you are to companies if you're worried about that. But also, it's, I mean, it's a pretty cool. I mean, my background is actually structures engineering. That was like the main section of my capstone. So like, this is like the kind of thing I like. Um, but lo and behold, I'm in flight test, so who knows what happens, right? Uh, but yeah, those are some of the thoughts that I have right now. Yeah, and general problem solving. If you can solve a problem with research, you know, you don't know the answer, but you know where to look, kind of thing. I think that helps a long way.
All right. So we're closing in. I'm gonna skip around. So, what courses did you find most challenging while you were at RPI? Because students see you guys are all doing well. It can't possibly be that you guys struggled at all while you were at RPI. But if you did, what would those classes have been, and what strategy did you use to kind of get out of it, help yourself?
Honestly, I probably like compartmentalized the ones that
Yes,
went
absolutely.
I was
I
like,
just,
I was trying to think about it. I was like, there were a lot of them that were very hard and bad. And that's engineering. But yeah, I specifically remember boundary layers and heat transfer. When I took it was very difficult. Now me and the Navier-Stokes equations were like this, like we get it. We're friends now, but we were not friends back then. And also physics too. I just wave theory, I was not working for me. I was not like clicking with it. For me, at least at the time, it just both boundary layers and heat transfer and also physics too. It was just like I'd never really learned things like that before, or like I missed the like ramp up between like more basic classes and boundary layers. So I just was kind of like startled and like lost a lot of the time. So wrapping my brain around those concepts was not easy, especially because I don't even remember how many classes I was taking every semester, but I know it was like 5 or something like that, and they were all kind of hard. So you know, like learning something that's really really different from what you're used to, and trying to like pass all your other classes that are not easy, that was like I think what really got me a lot at RPI. But you know, like Christy was saying, she had her sorority and her friends that she could talk to and work things out with. You know, I wasn't in Greek life, but I also had like a group of friends that like we studied together and we collaborated. And that was extremely helpful. It is extremely validating to have your friends be like, yeah, I don't get this either. Because then, you know, let me tell you, you are never like the dumbest one. None of you, no one's the most clueless person. Like you're all the same level of kind of clueless when you're starting out in the class. So don't be like ashamed of being lost, because I definitely think that office hours are really important. And as an undergrad, I kind of like did not go to office hours as much as would have been useful to me. But in grad school, I spent like a lot more time like interacting with my professors and my TAs and stuff like that. Although I guess grad school, you don't really have TAs the same way. But anyway, I was interacting with my professors a lot more, and you know, my grades were a lot better, and I was understanding and retaining concepts a lot better. So like, you know, at RPI, a lot of the professors are really cool. They pretty much none of the professors want you to be failing at the very least. So like, please use those resources, like especially as you get into smaller classes in your sophomore, junior, senior years, like go to office hours and also talk to your friends, or, you know, start a conversation with a classmate who seems to like have a better idea of what's going on than you. Like people most of the time want to help you. So definitely outsourcing, I think, was something that I recommend. Just looking for help outside of your own brain to look at things differently.
yeah, definitely office hours, TAs, or professor. I will admit that I was probably one of the worst students to go through RPI at times. I was the dumb kid that sat in the front and always seemed to manage to fall asleep midway through the lecture. And then later on, just be like, I have no idea what's going on. And so I really struggled with that. I actually do still struggle with my sleep, but that's probably more because of my longer hours I work now. But I would say office hours, TA office hours, those are great resources that you'll have all 4 years of your career at RPI. I would also say, do they still do the tutoring center for the entry level? All right,
Yep.
perfect. Yeah, that saved me so many times through a lot of the classes is going to the basically the tutor center and say, hey, I'm taking chemistry and I have no idea what's this. What is this? Really helped me. Definitely had more trouble with like numerical computation. I just couldn't wrap my head around it. I can still count in binary, but that's about it. Did not help me in life. But overall, yeah, I'd say TA office hours, professors, the tutoring center is always great. And even, it's interesting because you sit yourself in a room where you think you're the dumbest person, but you're at one of the hardest schools for engineering, period. So like you already had to get there. You had to be smart to get there. So you are smart. Like don't forget that. It's just yeah, it's hard. But everyone's got to do it. Everyone's gonna get through it. Just kind of buckle in and fly the seat of your pants a little bit, but figure it out. It's you will have opportunities to say, hey, I don't get this, and someone right next to you go, oh, I get it. Stick to them. They'll figure it out for you. And sometimes you won't know, and that's when I think the person who gave you the assignment probably knows. So he probably has the answers. So just remember that.
Yeah, definitely. I think ALAC is a good one to bring up as well as TAs. I remember going from, going to ALAC every week to then becoming an ALAC tutor. So it's cool to kind of see yourself come full circle and kind of level up. But I think also a really important thing is to make sure that you have your classes aligned in an order that works for you. Which that like I had so many conversations with Karen, kind of really nervous about the next steps when I was like currently struggling. So I think it's important to kind of ask, you know, what what kind of things you should take in which order, because I think for me, like, it definitely would have been more helpful if I took physics before I took IEA. And so it was like those kind of things where I think like, oh, I was just too late on that. Or if I set myself up and I talked to someone else and they let me know to take like Calc 3 multi before GPQ, and like that sort of thing I think really makes an impact, because some classes kind of jump ahead a little bit and expect that certain topics from other classes that maybe it's not required for you to take first. So I think it's important to kind of touch base with your engineering advisors and with other students who have already taken the classes you're gonna take.
Thank you guys. Those were very helpful, I think, for the students, new students, students just coming into engineering, people still trying to figure out what to do. Um, I know it's 7 o'clock, but I just want to go around one more time and just say, do you have any advice for them?
Yeah, so I'll be quick as possible, but I think touching a little bit on what we were just talking about, one of my biggest pieces of advice is please find what works for you. I spent a lot of time studying in the same exact way that my friends did. And then I was getting really bad grades and they were getting really like decent and good grades. And I was so confused and I felt that I was stupid. And it took me a couple of years to realize, oh, I'm just not learning things the same way they are. And as soon as I shifted the way that I studied, I was doing so much better. And I got through grad school using those like shifted methods, and like it really just improved my academic life so much to find what worked for me as opposed to trying to shove myself into a box that only fit other people. So that's definitely a big piece of advice. My other piece of advice is, if you're thinking about doing aerospace engineering, you should. You should do it. It's worth the work if you care about spaceflight or fixed wing aircraft. You know, it's difficult. And if you're like me, there's going to be times where you like flunk a test that you thought you aced. And I think that's maybe kind of a universal experience at RPI. But if you find it interesting, it's so worth pursuing. Like every day I go to work and I know I'm contributing to like a spacecraft that's going to land on the moon and like be a benchmark for human spaceflight. That's a huge motivator. It's something like to be excited about. And also, aerospace is an incredibly innovative discipline. You know, as you probably gathered, you can go so many different places with the knowledge that you get from your undergraduate studies. In grad school, I ended up in the astronomy department taking an astrophysical gas dynamics class, which was just like fluid dynamics in space. And I was like, oh, I like know so many of these concepts. And it's just not something you would even think about. Like, oh, I can do astronomy work with the degree I've gotten. Like it really will you know, turn up in places you don't think about. And something definitely important is like for women and gender nonconforming people, like you belong in this space as well as like anybody else. Like you deserve to be here. You worked hard to be here. I know it is a male dominated industry and sometimes it doesn't feel good. And it can be weird, but really like you belong here, like, and you will find your community and your niche and just like you will find what you're passionate about. So please like stick with it, you know, don't let morale get too low. Like you belong here.
Yeah, well said. I'd say persistence is key. You know, be stubborn. All right? If you reach out to a professor and they ignore you, reach out again. Go to their office hours. Be the annoying fly that's flying around my ear, asking for stuff. Because at the end of the day, they're gonna give it to you, whether they like it or not, really. So just ask the questions, right? And be go-getting, go for it. And if you don't really like it, try it out. I mean, if you're uncomfortable emailing someone, just email them. They're not going to judge you for a really poorly written email. I mean, I will admit, I've written some pretty bad emails out there. I actually recently just sent one to my captain, and he said some stuff about my poor email etiquette, and I did push-ups for it. But now I know, right? So it's always good to be stubborn about it, to be persistent. You know, failures will happen. You know, I remember I was senior year with flight mechanics for fixed wing, and I bombed a test. And I just thought I wasn't going to graduate. I was like, this is the last chance I'm going to get to graduate, and I'm going to fail this test, and it's 30% of my grade, and I'm not going to do well. But you know, I kept working the problem, and by the end of it, I find out I have a B plus in the class. I'm like, why is that? He's like, oh, it's by standard deviation, not by percentage. And I was like, oh, great. So I was like doing one of the best in the class, but I thought I was doing the worst. So, you know, keep at it, keep working the problems. I mean, you know, I hope most of you have watched The Martian, right? Mark Watney. Keep working each problem. You solve one problem, you go to the next. That's really what we're doing here. So, hey, go solve some problems, right?
Yeah, kind of taking what you guys just said. I think sometimes perseverance is a lesson that you have to learn, probably the most important one that you learn here. How to embrace failure and how to bounce back from it, because that it happens a lot. It happens a lot, especially here. I think it's something that you shouldn't be afraid of, which is hard to say. But everything does end up working out, and I think as long as you're reaching out to all your resources, that it'll be okay. And I think the real takeaway from like undergrad is like learning how to learn and like learning how you learn, because ultimately like you're not going to be sitting down and like getting out your calculator and like solving a textbook problem, but you're going to be using those same like communication skills and like technical skills to be able to solve real world problems at work.
Don't worry, there's plenty of textbooks, just FYI. You're not going to get rid of them, but
Awesome. Thank you so much to everyone here. Thank you to all our attendees. Thank you, Karen. This has been a very helpful, again, helpful conversation. Hopefully, um, the attendees, students got a lot of information, know where to start, maybe feel a little bit less alone hearing all these experiences. Um, if you do have questions, if you're an undeclared engineer, reach out to your advisor. If you want to come to the aeronautical or aerospace side, we will accept you. Um, but again, thank you everyone, the panelists tonight. You guys have been wonderful. And I look forward to seeing what you guys do in the future.
Thank you. Appreciate it.
Yeah, thank you.
Thanks.